In question 2a, and this is a three-part question, so we're considering the function fx equals sine inverse x plus 5. So the first part of the question asks us to state the domain and range of this function. So imagining this x plus 5 was our normal x, we know that x would be between 1 and minus 1. So for start, we'll say that x plus 5 instead, for our domain, that also should be between 1 and minus 1, because that is our domain for every sine function. Sine inverse function. So what we do now, we just subtract 5 from both sides. So 1 minus 5 is minus 6. And we'll leave x because now 5 minus 5 is 0. And 1 minus 5 would be minus 4. So that means that our domain is given by x is between minus 4 and minus 6. And to also top it off, you can say that x is an element of the real. So that just says that x is a real number. Now for our range, we know that because it's just a single x and all that, sine should be between pi on 2 and minus pi on 2. So now, because there is no extra constant outside, so we just know that y for our range, we know that y should just strictly be between pi on 2 and minus pi on 2. And again, we can quote that y is an element of the real. So those are your two answers for part I. So now we'll be moving on to part 2. So as I erase from our board. So now we've established that our domain, so I'll write it up the top here. So, and y. Okay, so now the second part of the question asks us, find the gradient of the graph at the point where x equals minus 5. So if we differentiate this, so we'll differentiate our fx with respect to x. So as we know, there is no constant term here, so the derivative of the inside is simply 1. So the 1 can go at the top here. And now we know that when we differentiate our standard signs, we get 1 minus x plus 5, and that will be squared. So there you go. And now at x equals minus 5, we know the derivative, so we'll say let x equal minus 5. Minus 5 plus 5 is 0. So then that would mean our df of x, the dx, is equal to 1 over square root of 1 minus 0, which as you should know is 1. So that's the derivative at x equals minus 5. And that is part II done. So the last question, part 3, asks us to actually graph this function. Graph y equals fx. So we just have to use part I and II now because it's pretty much shown us what we need to include in our graph. So first we draw our axes, we'll quote the origin, the x, and the y. Now for starters, we know that x should now be between minus 4 and minus 6, so pardon my scale, but you should know. So now also, since part 2 mentioned minus 5, we should also include minus 5. Now, as we know, it is between pi on 2 and minus pi on 2, as we've learnt from our range. And now all we need to do is graph. So we know that if we substitute our points, we'll find that minus 6 and minus pi on 2 go there, and that 4 and pi on 2 should go there. And now it's just a matter of drawing the endpoints. Make sure to label your endpoints. And since we've been told that the gradient here is 1, we'll also include that dy over dx is equal to 1 here.